Video starts, I would just like to mention that I do have a website. You can access it by clicking on the link in the description below. It's just ivanhung1.webnode.co.uk. I'll put it up on screen as well, but it's just a quick message to tell you guys that you can purchase my full videos in the full videos tab. It's £5 for all the unlisted videos that I'll be producing, which is the full version, which provides you with all the content that you'll need to smash your exams. So I hope this video helps, and I hope you enjoy it too. Hello everyone, welcome back to my channel. Today we are covering chain rule. This is the most basic rule out of all of them. So there's the chain rule, the product rule, the quotient rule, and there's also implicit differentiation. So we're going to be covering the basic one. Last time, if you saw the video, I covered product. That is a harder version and did require the use of chain rule. So for the free version, we're just going to be going through the rule. It'll be a quick video, and then with the full version on my unlisted playlist, we'll be going through a question. So both will be fairly similar, but the unlisted playlist will be one with combination of chain rule and product rule, so for like a little bit of extra understanding and practice. So let's just get started. So here we have the general formula. So I've been given these letters, or I'm giving these letters for the rule, because there's the n, which is usually to the power of something, and u, which is commonly known in differentiation to just be one of the variables of like some sort of function, if that makes sense. I'll try and make more sense in a second with numbers, but just in your head for now, this is kind of what it'll look like, but it'll make sense when I put numbers in. So today's example will be y equals 2x plus 1 in brackets all to the power of 4. Now we can see that there's a function, the function being y, and with the variables x, or inputs of x. So I've identified this part, right, to be u, and the 4 to be n. So before we get started on differentiating, we can see that we need to use the chain rule because there's more than one variable that we need to differentiate in one time. So if you're just differentiating normally, like, I don't know, something like x squared, right? You just differentiate that and it becomes 2x. But if it's something like 2x minus 7 all squared, like what we've got here, you can't really differentiate this one by one unless you go ahead and expand it out, expand the brackets, simplify it, do whatever you want, and then differentiate all those variables one by one. So chain rule is useful if you want to differentiate these kind of sort of in bracket kind of equations, if that makes sense. So like here, we wouldn't have to expand the brackets to the power of 4 to differentiate, and we would only need to just use the chain rule. So yeah, let's just get started. Hopefully that kind of explanation wasn't too clumsy and it made sense. So yeah, so dy by dx would be following the general formula, right? So we have, it states n, and n in this scenario is 4, so it will be 4 multiplied by u to the power of n minus 1. So what this means is that u, which is what we've got here, which is 2x plus 1, will stay the same. But whatever the power was before in the original function, so here it was 4, you subtracted by 1. So it'll be 4 minus 1, which is just 3. And then multiplied, this is the differentiating bit, if you haven't noticed, of just u. So u here I'll just do it in a different color. So u equals 2x plus 1, right? So this function looks pretty normal. We can just differentiate it normally. So we'll just go ahead and do that. So u prime or u dash will just equal 2 because only this bit has an x and it's to the power of 1. So obviously if you subtract it by if you subtract the power by 1, then it becomes 0. So anything to the power of 0 just becomes 1. So it's 2 times 1, which is how we got this here. So it will be multiplied by 2. And that is basically it. You're done. You just need to simplify this, right? So dy by dx equals 4 multiplied by 2x plus 1 to the power of 3 multiplied by 2, and you can further simplify that by multiplying the 4 and the 2 together, so it equals 8 and then in brackets 2x plus 1 and then to the power of 3, and that is your answer differentiated. So once you know, like in the exam, to like verify how you know if it's correct or not, you can integrate back to see if you got the correct answer, but that isn't the best way to do it. I would recommend just looking back at your working and following through the general formula instead of integrating, because integrating would just make this significantly harder and it's also a waste of time. So if you just follow the key rule and remember that you need to differentiate your u, uh, just to u prime, and then you sub it back into the formula, right? And you can get your answer. So it's not as hard as the product rule, as you could probably already see, but it can be a little bit confusing at first. So let me know if you need any help in the comments below, and I will see you next time.